In this analytical geometry problem, which at first sight looks insane, we've got this quadratic function y equals 8x minus x squared minus 1. And its graph is basically this blue curve on the coordinate plane. And there's this purple square crammed between the x-axis and the blue curve like this. And we actually want to find the area of this purple square. So if you want to try this on your own, now is the time to pause the video, because I'm starting to solve it right now. Let's call the distance between the origin and the square's lower corner a. Then the coordinates of the lower corner will be a0. Next, let's call the side length of the square b. Then the coordinates of this corner up here will be ab. And of course, this distance is also b, which means the coordinates of this corner must be a plus b and b. Now, the good news is we've got two very cool points on the blue curve, and we can use them to create two very cool equations by plugging their coordinates into this function. Now, let's start with the point AB. Here, A is the x-coordinate and B is the y-coordinate. So we replace x and y with A and B in this function, which gives us this first equation. Next, let's take a look at the point A plus B and B. This time, x is a plus b, and y is again b. So we replace x and y with those values, and we get this somewhat complicated equation. And we can open up the brackets like this. We will now use the elimination method by subtracting the second equation from the first one. These b's cancel out, and we get a big fat 0 down here. And on the right-hand side of the equation, these identical terms cancel out. So we are left with these guys. And we change their plus signs to minus and minus signs to plus, because this is a subtraction. And let's factorize the expression by taking out b like this. And we divide both sides by b to get this cool equation. And let's take these to the other side like this. And it turns out b equals 8 minus 2a. Now let's go back to our first equation and we'll bring it down here. We know b is 8 minus 2a, so let's change this b to that. And we can take this minus 1 to this side where it becomes plus 1. And 8 plus 1 is 9. And let's take this 8a to this side and it becomes minus 8a. And these two add up to minus 10a. Lastly, we take this minus a squared to the left and it becomes plus. And we get this awesome quadratic equation which factorizes into this, and it turns out a is either 9 or 1. First, let's check for 9 by assuming this point AB is actually 9b. We know this point must be on the blue curve, so let's put the coordinates 9 and b into this function to see what happens. We do the math, and we end up with b equals minus 10, in which case the coordinates of the upper corner of the purple square have to be 9 minus 10. Which is impossible, because the point 9 minus 10 is under the x-axis, somewhere in this region. But the purple square is above the x-axis, so we rule out 9, and we are left with 1 as the only viable value for a. That means this point's coordinates are 1b, which we can put into this function and do some math to find that b equals 6, which is a completely acceptable number. Because the point 1, 6 is in the correct region of the xy plane. We've just found b, which is the side length of the purple square, and it's 6. And now my son will find the area of the square. Go ahead, son.
To find the area of a square, we must multiply its side lengths by itself. The side length of this square is 6, so we take the square of 6, and it's 36.
Thank you so much, son.
I went to the dentist, and she pulled 2 teeth from my mouth.
Yes, your front teeth didn't want to fall on their own, so we had to see the dentist for that. But you're going to get your permanent teeth, right?
Yes!
And so that's it, people. We found the area of the purple square, and it's 36. If you enjoyed this video, please push the like button, and don't forget to subscribe so that you don't miss our future videos. Have a good day, and see you soon.